Hello everyone, my name is Aista and I am pleased to welcome you all to the webinar, Integrating Safety and Reliability Analysis into MBSE Toolkit. In this webinar, you will learn the value of applying the model-based approach to safety and reliability analysis and integrating it into MBSE Toolkit. The presenter will share experience of NoMagic in building and applying model-based safety and reliability analysis in practice. Our today's presenter is Andrius Armonas. Andrius is the product manager of MagicDraw and Cameo Collaborator with more than 10 years of experience in software development. He also works with major clients and ensures that the internal development team knows and understands the strategic directions and customer demands. Andrius has conducted numerous trainings in Europe. He holds a PhD in informatics engineering from Kaunas University of Technology. Before Andrius starts, let me remind you that today's presentation and demo will take about 50 minutes and the question-answer section about 10. And one more thing, if you have questions, you don't need to wait for the question-answer section to ask them. You can do this during the entire session, and Andrius will answer them later on. Type your questions in the questions area. Due to the limited time, some questions may be left unanswered. In such case, answers will be published later at the webinar's page in written form. So, Andrius, are you ready to start?
Yes, sure. Thanks, Aista. So let's start the webinar. So this is a brief agenda of today's webinar. We'll start with the scope. Basically, we'll cover just a couple of most important terms that we'll use throughout this webinar, as well as we'll cover the topics we're going to discuss in this webinar. Then we'll briefly discuss what are the internal efforts within NoMagic related to model-based safety and reliability engineering. And finally, I will show the demo. In that demo, you will see basically model-based FMEA support in MagicDraw, and we'll also show the model-based safety analysis. So I think that the demo will take most of this webinar time, and I hope you will enjoy it. If we talk about the scope of this webinar, so we'll be touching just two very important topics. So one is reliability and the second is safety. There is a third very interesting topic for us, it's cybersecurity, but we'll not be touching cybersecurity in this webinar. So what do we mean by reliability? So for us, it's the ability of a functional unit to perform a required function under given conditions for a given time interval. And safety is freedom from unacceptable risk. So these are definitions taken from standards mentioned here. And as we mentioned, we'll cover just these two aspects in this webinar. So during past several years, we observed quite a number of our customers who built plugins for MagicDraw to support model-based safety and reliability analysis. And that number is growing. So last year, we started internal effort in NoMagic. We started talking to these customers and analyzing their different implementations. We tried to understand what's the value, why they are doing these implementations, and how do they benefit from that. And basically, our effort is very much aimed at reconciling these efforts, merging them into a single foundation that we could provide. And in this webinar, we are presenting the very first results. Basically, we already have a free plugin, which is called Cameo Safety and Reliability Analyzer. It's available from the plugin manager. So if you are interested, you can immediately download it and try it. It's free. It has samples bundled. I will be demonstrating one of these samples in this webinar. So we already have something to show, but more is coming in the future. We are also analyzing standards, various standards around safety and reliability. There's also a lot of scientific and industrial papers on this topic, so we have a huge pile of that as well. And there are existing tools, right? And then one of the probably most famous tool and then popular tool for doing this, for doing reliability and safety analysis, is Excel. But despite being Excel very popular, there are other tools not model-based. So we are looking what they have. And the last thing is, but also very important one, is that there is a new group at OMG. It's basically trying to standardize a profile for safety and reliability analysis. We are part of this group, and we hope that next year we'll have a official standardized profile for doing these types of things, and that's going to be integrated with SysML. Okay, so our work scope is basically described in this slide. As you know, there are several methods for doing reliability and functional safety. Basically, one of the most popular methods for reliability analysis is FMEA or FMEA, and we already have support for that. I will show that in my demo. There is also a very popular method, fault tree analysis, FTA. We have just started working on this, so we don't have anything to show yet, anything substantial at least, but I think that this year we'll have an implementation of that as well. And then if we take a look at what functional safety is and what that means to different industries, we see different needs and different standards for performing safety analysis. So what we observed from our customer implementations, so these implementations actually fall into one of the four groups. So basically, it's either comes from the medical, from automotive, from rail, or aerospace fields. Now we already have the very initial implementation of functional safety for medical devices and software. We are also looking at automotive. It's ISO 26262. Also, we haven't yet started working on rail and aerospace, but we will be doing that, I think. So what's interesting is that if you talk about the reliability, so FMEA's fault tree analysis is very common, and it's used in all industries in more or less in the same way. So it's pretty easy to provide a single implementation, a single solution for that. That works in all domains. If we talk about the functional safety, every domain has its own standards. So we prepared a very nice slide about that, about functional safety. And there is a meta standard called IEC 61508, and there's adaptations of this standard to different industries. So as I mentioned, we are trying to provide not just support for the meta standard, but actually provide implementations and profiles and all the reports and so on and so forth for each industry. So as I mentioned, we already have support for ISO 14971 as well as the IEC 62305-04. And as I mentioned, we already started looking at ISO 26262. So if you are applying these standards and using these standards in your company, so we would really be interested to hear from you. What are your needs? What would you expect? And you can already try implementation, at least for the medical devices and software. Okay, so now let's start the demo itself. So we'll be looking at a very, I would say, a very simple scenario, but it's quite a common one used for designing medical devices. Again, this is just an example, and our tool covers many use cases, but in this demo I will be demonstrating just this example. So our company was, as you know, is actually famous for providing model-based systems engineering toolkit, and basically what people are doing with it is basically they are designing systems, but there are two additional groups. Typically it's a cross-functional teams working in parallel to the systems engineering teams. So one group is the reliability cross-functional team, and the second team is typically a safety cross-functional team. And these three groups, basically the systems engineers, the reliability cross-functional team, and safety cross-functional team, they all actually exchange a lot of information between each other. So I'll start my demo from the very standard SysML model. So we'll be looking at the design phase just very briefly. And now I will be switching between PowerPoint and MagicDraw. Okay, so now let's switch to MagicDraw. So in here, I have a standard example that comes with the Cameo safety and reliability analyzer. It's not modified, so you will actually see it if you download the plugin yourself. So now if we take a look at this model, so it has the design package that contains very simple SysML model for insulin pump. In this demo, we'll be analyzing insulin pump. I hope more or less most of you have an imagination of what it does. So this SysML model demonstrates and shows that the pump has a display, it has a battery, it has a beeper, it has a TVSS, it has a dispenser, control module, and sensor. There's nothing else in this model. It's a very simple one to understand. And as you can see, the pump itself has these parts, and we'll be analyzing these in our next steps. So let's go back to the PowerPoint. And in here we can see that there is basically the reliability cross-functional team who performs reliability analysis. So in our implementation we have failure mode and defect analysis support. There is also another popular method, fault tree analysis support, and support for it is coming as well. So now we will show how to perform FMEAs in MagicDraw. So let's go back to MagicDraw. So basically, as you can see, we have the pump, the parts here, and now there is a separate package devoted for reliability analysis. Now let's expand this package, and there is FMEA sub package underneath. So let's expand it, and we can see there is a table called FMEA. So if I double click on it, I get an FMEA table open. So it's a very standard view that you typically have in your Excel or some other tools. So we tried to provide that to you in modeling tool so that you don't have to, learn how to, do the same things in diagrams, basically so that the transition from Excel to model-based approach would be as easy as possible. So in this table, you can see very standard things, like rows and columns, which correspond to different components within FMEA. And each row represents an analysis item for FMEA. So it starts with an ID, which is a unique one, and it's automatically generated. You can customize the rules if you don't like the naming rules of your IDs here. You can assign a friendly name to your FMEA analysis items. This is something you not typically find. You don't typically find in Excel, but you don't need that in Excel where you need that in modeling tool. When you assign a friendly name, that name will be visible in diagrams or some relation maps or matrices. This is a very beneficial thing to do. Then there is a classification. So basically it can be, this failure mode can apply to electrical and mechanical software parts of your system. So some companies call it discipline, so we call it classification. And then there is an item. So again, this is a very standard FMEA component that you have, and we have it as well. So an item in our case can be anything. Typically that's a part or a block, but it can as well be a function, like an activity or an action. It depends on how you actually do that already. So in this particular example, we are demonstrating that an item is a part. And for example, if you want to assign a part, so you can simply browse through your model and drag and drop items onto your FMEA table. So for example, if I want to assign dispenser as an FMEA item for the last item, right? So FMEA item, I can just drag and drop it and assign it. As you can see, it got assigned to this last row, and I will just undo the action because I just shown the capability here. Okay, so this is a very standard type thing that you do typically, and as I mentioned, you can add or drag here blocks, parts, functions like activities, or even requirements. So then the next thing you specify is the failure mode. So basically, in this particular case, how our battery can fail. So for example, in this particular case, you can see that the battery may not be charged in this particular case. And then there are two additional columns we have. It's just local effect of failure as well as the final effect of failure. So local effect of failure is just the effect on this component, typically on the element itself, and the final effect is the effect on the end user. So these are two different different levels of effects. So in this particular case, if you have a battery which cannot be charged, then the final effect for the patient can be overdosing or underdosing of insulin. And then you evaluate the severity of your failure mode. So in this particular, it's 4. It's a really high severity, where the therapy delay can be not as high, and so on and so forth. So the next standard column that we support is a cause of failure. So basically, what's the cause of this failure mode? And you can specify, for example, that the battery has degraded or depleted, and so on and so forth. So these are pretty standard things that you do in your Excel. But if you observe and see the difference in this table, so the very important thing here is that all of these items are reusable in the model. And that's a very different thing from what you have in Excel. So if you take a look at your final effects or your, for example, causes of failures, these items come from packages called failure modes. If you take a look at my browser, so there is a failure modes package which contains unique, consistent failure modes, which I can take and use them in the table. If I go to the effects of failures, I can see the final effects of failures here and the local effects of failures. And if we take a look at the causes, so then we have a consistent list of causes here. So, and for example, what's important here is if you have a new item, like the second item, or if I create a new item, let's create one, analysis item, and the cause is the same. I don't have to type in again the same name like battery has depleted or battery is overcharged. I can select the desired cause of failure from my my package, or which can be actually exported into a separate module, and I can simply drag and drop it into this table and set it. And once I change the name of this, cause of failure in my model, it gets changed in all tables. So what you typically end up in Excel, so you end up in 5 different variations of incorrect operation, or 5 different variations of battery depleted. It's really difficult to maintain the consistency of your, FMEA analysis in Excel and in some other tools where you can exploit here modeling benefits very nicely and then elegantly. Okay, so all of these items like the failure modes, the final effects of failure, local effects of failure, causes of failures are all reusable, and you can export them into different modules and reuse not just in this project but in other projects, new versions of your projects, and so on and so forth. And even it's possible to enforce such rules that, for example, if you are developing insulin pump and basically you're releasing the second version of this insulin pump, so you expect that most of the failure modes and causes would come from the previous analysis already. So you can actually check automatically that basically the reusability is there, and then that you exploit the previous analysis well enough. Okay, then if we go further, there is an occurrence property, which basically where you can specify the likelihood for the cost to occur. And here you can see the different values here. All of these values again are customizable, so you can actually have your own ranges. For example, we saw the companies which use just 1 to 3 or 5 ratings. Others use from 1 to 10 and so on and so forth. So all of this can be customized, as well as the suggestion lists. So for example, in your company, if you already decided to use 1, 2, 3, 4, 5 in the ratings, so the product is customizable, and you already suggest the possible values here. Or if you have different ratings, these suggestions lists are customizable. Then again, we have 2 different standard things again, like prevention controls and detection controls. I will not explain what these are, as most of you know probably if you apply FMEA. And we have detectability rating, and then we have the product of occurrence and detectability. So the product it's in here demonstrates just the capability to calculate the risk priority numbers or some other values automatically. In this particular case, we use the product. Basically, we multiplied occurrence and detectability, but you can customize this function. So if you have, and that what typically happens is that companies have their own functions, not they don't multiply things. So you can as well easily customize that. And finally, there is a risk priority number, which is a product of severity, occurrence, and detectability. And this is again a customizable thing. Just for those who are curious how to do that, I will demonstrate a very simple example of this. You go to your browser, and then there is a safety analysis configuration. You just double click on it, and there is a score expressions. So this is just an example of how it's done. So it's done via script, and here you can see a JavaScript where you can enter your function, any function you like, to evaluate risk priority numbers. Okay, so now let's skip the next 2 columns, which are called hazard analysis reference and requires hazard analysis. We'll get back to this later a bit. Then there is recommended actions, so it's some kind of description of how you're going to reduce the risk priority number. And then there is mitigation. So this one is very important. In here, you specify the linkage to your safety requirements. So basically, how do you mitigate this specific FMEA item? And if you take a look at the FMEA package here, so we have a requirements sub-package. Basically, it has safety requirements in here, and from safety requirements, you can introduce new SysML elements under your design package easily. Then you can enter other standard things like responsibility, target completion date, action taken. Again, you can enter new values like reduced severity, reduced occurrence, reduced detectability, and finally, you can see reduced values like product of occurrence and detectability and risk priority numbers. So you can see easily that, for example, from the risk priority number went from 48 to 8 in here. So it's all visible, and you can even write validation rules, which, for example, check too high numbers and so on and so forth. We did not provide these validation rules out of the box because we don't know whether 48 is good or not. It depends on your company rules. But that capability is there. It's really easy to write these validation rules and make automatic checks if there is a need. Okay, so I think that we can get back to our PowerPoint slides. So we covered reliability analysis pretty much. So what we saw that we basically went through the design and analyzed each element in the design with FMEA items, right? So we created an FMEA item, at least one FMEA item for each part. So we basically created a linkage. We linked our design SysML model to the reliability analysis. And then we also saw that there is a linkage from reliability analysis to requirements. Now let's go to the next phase, analysis phase. Basically, there is another group called safety cross-functional team, and they typically use their own standards. And these standards, as I mentioned, are different for medical devices, for aerospace, for rail, or automotive. In this particular demo, I will show implementation of how that's done for medical devices. But that's, again, for different industries, there are different implementations and standards for this. And there will be a link between reliability analysis and safety analysis. So let's have a look at that. So let's switch back to MagicDraw. And in here we have a separate package called safety analysis, and I will expand it. And it has some other sub-packages in here. So let's open up the risks package here, and it has a risks table. So let's open this table. And again, it has pretty much standard things that you are typically used to when performing safety analysis for medical devices. One of the, again, all items are numbered, have their own unique IDs like R1, R2. This can be customized. We'll skip the FMEA reference for now when there is initiating cause. So this can be a friendly name or just a free-form description of the initiating cause for your, risk. And then there is a very standard thing called hazard and risk hazard analysis for medical devices. So it's basically a potential source of the harm. And we'll start here analyzing, again, we are analyzing the insulin pump. So what can be a hazard? So a potential, source of harm can be a dose, for example, or an electromagnetic energy. And then there is another concept called sequence of events. So basically, in this particular case, we are saying that, well, what can happen wrong, right? So the battery can sink, or basically, if we have the electromagnetic energy, the electrostatically charged patient can touch the pump, right? And then we have the hazardous situation. Again, this is something that comes from the standard, and we do have support for this. So basically, in here, we can see if the battery sinks, so the user receives less insulin than required, and if the patient touches the pump with electrostatically charged finger, so basically there can be a failure to deliver insulin as well. So just like in FMEA, you can see all of the hazards, sequences of events, and hazardous situations. All of these are reusable concepts. And if we go back to the containment tree, we can expand the hazards here. So it's a consistent set of hazards, hazardous situations in here, as well as a sequence of events. So all of these items can be exported into different modules and enforced to be used in different versions of the products. So we saw this used in practice a lot already, and it's very beneficial to maintain your consistency in your analysis. Again, so yeah, and the last thing that comes again from the standard is the harm. So basically, it can be, in this particular case, if you have as a hazard that is dose, and the sequence of events is that the battery has sank, and the hazardous situation is that the user receives less insulin, so there can be three different consequences, three different probabilities probably. It's like coma death, increased consciousness, decreased consciousness, and minor organ damage. So we can see that then you can evaluate, the severity of these different harms. So 4, 3, and 2 in this particular case. Then there is, again, mandated by the standard things like P1 and P2, its probabilities. P1 is the probability that if you have a sequence of events, you will get the hazardous situation. And P2 is if you have the hazardous situation, how likely the harm is to happen. So again, we evaluate these values as well. The ratings are customizable. If you again use different ranges, so it can be easily customized. And then there is a P. P is a product of P1 and P2. And then there is some additional items like detectability, correctability, and product utility. not every company is using them. If you don't use them, you can basically skip them and hide from this table. If you use them, this will be of benefit. And finally, you evaluate risk. So risk is automatically calculated. In this particular case, it's a product of these ratings. But in most of the cases, it's not a product. It can be like a function again, and that function can be customized. And the last column is use-related. So if that risk is associated with how the user uses the product, for example, he forgets to charge the insulin pump, so then you can simply select this checkbox. In the future, in next iterations, we are going to introduce a linkage to use cases here, because use cases represent how the user interacts with the system, and basically if in some step, basically in the model, that will be an action in the activity, there is a risk. So we want to be able to reference these activity actions directly from here instead of just marking, the checkbox here. Okay. So let's go back to the FMEA reference column. So basically, the FMEA reference column is related to the FMEA table, and we can have a look here. So let's go back to the FMEA table, and when the reliability cross-functional team is performing their analysis, some of the items, some of the failure mode and defect analysis items can cause fatal, errors or consequences. And in these types of cases, like injuries or deaths, so when that reliability team thinks that this or another item requires attention from the safety cross-functional team, so then the reliability guys can check checkboxes here by marking that, for example, this FMEA item and this FMEA item and this FMEA item, basically 3 items, require attention from safety people. And then what happens is that safety people can, they have a package called FMEAs to be analyzed. It's under the safety analysis sub package here. So it's a smart package, and it shows FMEA items that safety cross-functional team needs to address. So basically, smart packages are not simple packages. They show contents by a query. So basically now this package collects all FMEA items which haven't yet been addressed. So if we take a look at our table here, so we have 3 items. One item is this, this, and this. And under this package, we have just 2 items. So why is that? Well, because we already have a reference here to the risk which addresses this specific item in this table. And if we go back to the risks table, so we can see that there is a back reference to the FMEA item. It's called F1. So here we actually employed the names. So if we have the second item, for example, like F2, and we want to address it with the R2 risk, so we can drag and drop it, and we can see it set for this risk. And if we go back to the FMEA table, it's automatically refreshed for us. We can see that the second item has already been addressed by the R2 risk. So we can see just that only one item left for basically for reviewing by the safety cross-functional team. If we refresh our containment tree, I go to the view and then select the refresh menu item, we see that just one item is left in our backlog for the review. So this way, the reliability cross-functional team, they can easily see and track how many of the items they basically marked as the ones needed for analysis from the safety cross-functional team. They can see that how many of these items were already addressed by the safety cross-functional team, and the safety cross-functional team can easily see basically what items are pending for the review. So it's a very important aspect in here. Okay, and let's now go to the one more table. It's called risk with reductions. Okay, so I will zoom in a little bit, and we already covered hazardous situation, harms, severities, P1, P2, and other ratings. And now let's start the discussion on how do we mitigate risks. So we identified some of the risks, which some of them are high, medium, low priority. Then we can enter the risk control measures description. And then, again, just like in FMEA case, we can create safety requirements. So in this particular case, we can install an alarm into the system. So, for example, when the battery sinks, so we can basically set an alarm, and it informs the user that he needs to charge the pump. And that safety requirement is stored in a separate package. And if you expand the safety requirements package here, so there are two safety requirements for us, and these safety requirements are ordinary SysML requirements. So from these SysML requirements, you can create and link new design elements. In this particular case, we created a beeper block. It can be a part, anything else. So this way, how do we mitigate that? And then we evaluate again. We have reduced severities, P1, P2, P, and we have reduced evaluations like reduced risks. And we can see that. Let me zoom out a little bit, that the rating from high went to low here. So basically we addressed, mitigated successfully this risk in here. So yeah, so as you can see, if we go back to our slides here, we have a very nice linkage between reliability analysis and safety analysis. So and we also have, from safety analysis, we create new requirements, and from these new requirements we create new design elements, and these new design elements require additional reliability analysis, right? And this reliability analysis may imply additional safety analysis, which will introduce new design elements, and you loop the cycle in again and again. So these are very nice things that you can do, and as you can see, if you do it in a single tool, which is basically a model-based systems engineering toolkit, you get a lot of benefits from that. Let's go back to MagicDraw, and I will show just a couple of additional diagrams that we built, again, just to demonstrate the value, but you can build a lot of analysis tools around that. So if we take a look at the design package here, so we have a couple of matrices. One is the traceability between the design and the failure. So you can see here how much of your design is covered already by FMEA items, right? So it's very nicely shows that the control module hasn't been covered by the FMEA items. And again, for example, this is a very simple thing to do in a modeling environment like MagicDraw, and it's very difficult to do that in Excel, for example, these types of analysis. Then if we go back to another matrix, it's the coverage of our design with risks. So we can see, for example, which risks introduced what design elements. Again, a very important and interesting analysis. What else we can show here? Yeah, we can see another very interesting table here. Again, this is an experimental table, which lists all design elements, and we can see directly in one table how it links to our reliability analysis and how it links to safety analysis. So again, one more view of what you can build. As I mentioned, this plugin is a very new product we are building, so it's in technology preview state. So it will evolve rapidly. So if you have additional ideas, what could be, built in here, so we are very open to collaborate on that. So now let's go back to our slides. I think I am more or less finished with my demo. Maybe just a couple of closing notes here. So if we just think about what the benefits model-based safety and reliability analysis brings, so this is a summarizing slide. So one of the things is that you have just less time to spend, if you want to demonstrate to the regulatory bodies that risks addressed by safety requirements or risk control measures, design elements, critical quality attributes. So, in the document world, it is really time-consuming and error-prone to validate, the document to ensure, that each risk is properly addressed by making changes in the design. And what is easy is basically you can easily automate validation of the model if you want to ensure that entire design went through safety and reliability analysis. And if you take a look at Excel analysis, it's really difficult to ensure that all your design went through these analyses. One of the things our customers are saying that this actually helps in introducing or helping building more agility between design, safety, and reliability analysis phases. Basically, users observe a lot frequent exchange of information between safety and reliability analysis cross-functional teams. They observe shorter development cycles followed by shorter, safety and reliability analysis cycles. And basically, these things lead to a lot more precise detections of risks and faults, and basically, in the end, safer, more reliable products. One more nice thing, as you saw, is really nice and short two-way traceability between safety and reliability analysis. Well, in practice, separate cross-functional teams are working on safety and reliability analysis, and it's important that the safety group can effectively review and analyze fatal faults identified during the reliability analysis. And on the other hand, reliability analysis cross-functional team needs to be aware that fatal faults they identified have been reviewed and addressed by the safety analysis cross-functional team. So, if you have any questions, so I think it's time to do that, right?
Yeah. It's time to switch now to the questions and answers section. And now, please give us a few minutes while Andrius reads the questions and prepares for answers. So we are back, and let me read the first question. How did the functions got into FMEA table? Are those imported from design functional model?
Okay, so I think for that we need to switch back to MagicDraw. Let me do that. Okay, so if we go back to the FMEA table here, so in this particular case you don't actually see functions directly in this example. What you actually see is you have the items which are parts, and yes, they are imported. Well, imported is not probably the best term to use here, but they come from the design model. If I right click on that item here, the battery itself, and I can select it in my containment tree, so I can select the part property battery, right? Okay, so, and it's placed here under the pump, so it's a part. But of course, if you have functions modeled using activities, so we do allow that. You can take these functions and drag and drop on the item cell, and you will see functions here as well. Again, I'm not sure if you meant, what did you mean by function, but probably that. So I hope that answers the question.
Also, the second question. Is it possible to include lists of events that already exist as individual events, as sequence of elements? Because it looks like the sequence of events is an individual string. There are more properties?
Okay, so if we go back to the risks table here, so and go back to the sequence of events, yes, you're correct. It's essentially it is a string, and if I select it in my containment tree here, let's collapse these other packages. So yeah, we can see the sequences of events here. So these sequences of events are actually elements that only have a name. So that's all they are. So as you can see, for example, if we have electrostatically charged patient touches infusion pump or something like that. So yes, there are no different steps here. It's a string, and you can just add steps as new lines here. So if you have just the first step and you want to reuse it in another sequence of events, so currently it's not possible to do that without copying and pasting it. So in this particular case, you would need just to copy and paste it. But we actually are open to ideas in here, and we can, if there is a real need for that, so we are open and we can add that pretty easily.
What's the rationale to have a reliability group to say what requires a safety hazard analysis and not the other way around?
Okay, so I think that's first the reliability cross-functional team. It doesn't necessarily require, you know, these safety analysis. It just marks the items that can lead, you know, to some fatal consequences. So this is their thinking. I mean, their impression is that probably this could be analyzed, and this is just you know, providing information to the safety group. The safety group then will take, you know, these items and will use their own methods to analyze them. And it might be that it's not true. It doesn't actually lead to fatal consequences, and so on and so forth. And this is just, again, a demonstration of what's possible. And we can do it differently. So we can, I mean, in this particular example, we don't show it, but it's possible to relatively easily extend these tables and add the opposite, you know, where you mark, you know, these items, the risks, and then the reliability cross-functional team exactly in the same way takes these items and analyzes. So it's also possible. We just don't demonstrate it in this example.
Is there a benefit to tie this capability into constraint block and parametric diagrams? Are there plans to do so?
Yeah, so that's a very interesting topic. It's not the first time that we hear about it. One of the things we are thinking about is that we should somehow integrate it into our simulation toolkit, because with the simulation toolkit you can explore the to-be system, and if it fails at some point, it can provide information to your FMEA analysis or risk analysis. Definitely that's on our focus. I don't think this will happen this year, but we'll be looking at this next year, I think.
What report formats are created?
Okay, that's an excellent question. So let me show you a couple of reports that we have. The plugin comes with two predefined templates. One is FMEA template, and the second is risk and risk reductions template. So definitely you will want a standard Excel file out of this, you know, model. So what you do is just generate an FMEA analysis. I will do that. And we'll get a very standard Excel view, and yep, so here it is. This is exactly what you typically build by hand in Excel. So instead of doing that by hand in Excel, you can generate consistent Excel files, Excel documents out of the model that's validated, and that's you know, is consistent. So yeah. So as you can see, all of the information is here. It's like classification item, failure modes, the design controls, all of the things you typically do. And this is also customizable. If you don't like something in that table, you can customize the appearance, you can add columns, you can remove columns, whatever you like. And the second report is for the risks, for the safety analysis. If I click on it and then generate the report. So let me just switch to another view. Yeah, so we can see again a very standard risk analysis table here, where the initiating causes hazardous situations in one cell, then pre-mitigation scores, post-mitigation scores. Yes, there are some other items like displayed in this tab. It's a simplified, you know, view of just risks without past mitigation. There's a title as well predefined for you. So definitely those who will be using this, they will be customizing it easily. Okay, so I hope that I answered this question. And one more thing, maybe just for your information, we have a Cameo Collaborator product. So this product allows, disposing information on the web, so you can publish these tables, all your analysis in a web interface, and provide that to other teams who may not necessarily be using our products, and then they can make comments on these tables and then provide feedback via comments in the web interface on these analyses. Okay, so do we have any other questions?
Yeah, we got many questions, but we are running out of time, and I just want to say that really make sure that you all get all these answers in a written form, and the document with the answers will be published at the webinars page.
Yeah, so thanks everyone for joining this webinar. And as I mentioned, this is an ongoing work, and we really look forward to cooperating with customers and to your ideas. So let's keep in touch. This is an email, and it's specifically devoted for our group, and then everyone who is involved into that reads these emails as well as I do. So just drop us a line if you have any ideas or interested on this to talk about these topics. Okay. So thanks everyone.
Yes, thanks everyone.
And have a good day.
Yeah, we hope to see you in the upcoming webinars. Goodbye.
Goodbye.